This will be a question by question walkthrough of the Unit 2 review. As we are going through this, if you have any questions, comments, I'm not sure how she got that, thoughts, go ahead and jot those down to the side, and you can send me your questions on Remind tonight, and I will definitely answer them. Let's start with number 1. Number 1 and 2 were asked to count slope. I don't have points. I could get ordered pairs, but if I have graphs where I clearly have 2 points that are chosen for me, let's just go ahead and count. So I know that I'll be counting change in y divided by change in x. Change in y is a vertical change, which means up or down. And then my change in x, left or right. And I had that written down for you on the sheet of hints, so you can reference that at any time. So we have talked in the past how it doesn't actually matter which point I start at. So I choose this one. If I start here, I need to count up or down first. It doesn't make sense to go down because no matter what I do left or right, I couldn't get to any points. So that's how I know I'm going to count up 1, and I'll record that right here. Up 1, left 1, 2, 3, 4, 5. That was left 5. Up 1 is positive 1, left 5 is a negative 5. My answer is negative 1/5. And I can check. I have a negative answer here. So if I see I have a negative answer, I should have a decreasing line. And if I look at this line left to right, it is decreasing. I am in good shape. On to number 2. Process has not changed. Change in y divided by change in x. Let's start at this point. So I'll count up 1, 2, 3. And then right 1, 2. My answer will be a positive 3/2. Up 3 is a positive 3, right 2 is a positive 2, and I'm done. If I had started at this ordered pair here, I should get the same answer still. From here I would have counted down 1, 2, 3, and then left 2. Well, down 3 is a negative 3, left 2 is a negative 2, so this would still simplify to 3/2. And I have a positive slope, increasing line. I know I'm in good shape. 3 and 4, I have no graph, so we know we'll be calculating our change in y divided by change in x. So in the past we've talked, if it helps, line up your points. So 9, 6, 1, 19. It puts the y values together and your x values together. So I know change in y divided by change in x will be, you could choose to do 19 minus 6 or 6 minus 19. I'm going to go with 6 minus 19. If I do 6 minus 19 in the top, I have to respect that same order. So if I did 6 minus 19, in the denominator I will do 9 minus 1. 6 minus 19 is negative 13. 9 minus 1 is 8. There's really nothing I can do to reduce this. 13 is a prime number. What goes into 8, 2, and 4. Neither of those goes into 13, so we're done. Again for number 4, let's stack our points. 15, negative 4, and 6, negative 19. Change in y divided by change in x. Let's go with starting it with a negative 19 here. So I have negative 19 minus a negative 4 up top. Watch those negatives. Negative 19 minus a negative 4. Notice how I used parentheses here. If I do negative 19 minus negative 4, in the denominator I must start here with 6 minus 15. Minus minus becomes addition. So this is really negative 19 plus 4, which is negative 15, divided by negative 9. I know negative divided by negative is positive. Both 15 and 9 are divisible by 3. 15 divided by 3 is 5. 9 divided by 3 is 3. So I know my final answer will be a positive 5/3. If you stopped at 15/9, it's not that you're wrong, it just means you haven't fully reduced your answer. My fully reduced answer will be 5/3. Very good. Identify the slope and y-intercept. As soon as you see the word slope, I would always recommend put an M above it, and above y-intercept, B. Here, if I look, I see that I have slope-intercept form. Y equals mx plus b. Pardon the typos here with the smart slate. It's giving me some trouble. Y equals mx plus b. There we go. So here I have my slope. B is my y-intercept. So all I need to do is accurately identify, here's M, here's B. So for number 5, M equals 1/4, B equals -1, and I'm done. Making that a little neater. Okay, number 6, same process. M equals B equals. I can go straight to this because again I have y equals mx plus b given to me. M will always be the coefficient next to x. So here m equals -6, b is -5, and I'm all done. That was all that was required for these two. Accurately identifying m and b. Number 7, find the slope of a line parallel to the line, and I have a line. Parallel lines have the exact same slope. So ask yourself, what slope does this line have? Well, I see this negative sign. We know that that negative sign really represents a -1. Parallel lines have the exact same slope, so the line parallel to this one must have a slope of -1. And I'm done. Exact same. Now number 8 says, find the slope of a line perpendicular to the line. So for perpendicular, we know that we must have opposites, reciprocal slope. Opposite meaning flip the sign, reciprocal flip the fraction. So first let's identify what we're starting with. I have a starting slope of 1/2. So I see that I have a positive value. That means my perpendicular slope must be negative. 1/2, the reciprocal of 1/2 is 2 divided by 1. So my perpendicular slope is -2. Number 9 asks us to graph y equals -1/3 x minus 3. As soon as I see that function, I really hope what comes to mind is y equals mx plus b. I already have slope-intercept form. I know right away my slope is -1/3 and my y-intercept is -3. We'll graph this piece first. So I go to my y-axis, I plot -3 on the y-axis. From here, we'll use the slope as a set of directions. This will mean down 1, right 3. Down 1, right 3. So from here, down 1, right 1, 2, 3. Down 1, 1, 2, 3. I could have counted the other way, so coming back to my intercept, the opposite of down 1, right 3 would be up 1, left 1, 2, 3. And I could keep going, but this is plenty of points. We talked in class how straight, nice, neat lines are a must. So ID or a piece of paper folded in 4s, note card, whatever you choose to use as a straight edge, works for me. As long as that line comes out nice and straight, and it's a line, so we know that we will have arrows on both ends. If we check, I have a negative slope, so ask yourself, what kind of line should I have? Negative slope, decreasing line. Let's check. I have a decreasing line left to right. It's going down. I am done. Very good. Number 10. What's different about numbers 10 and 11 is I do not have y equals mx plus b. I want it though, that's my goal. So y equals mx plus b. That's what I need first. So let's draw a line down the equal sign. Trying to solve for y. What I mean by that is that all of my attention is on this variable right here. My job is to see first, on this left side of my equation, is there something I could, quote, move over using addition or subtraction? And the answer is yes. The opposite of a positive x is a negative x. So we'll subtract x from both sides. That leaves negative 2y on the left side. Here these are not like terms, so I'll just write it just as I see it. Negative x minus 6. Last step, divide by negative 2. Now, I highly recommend you show yourself dividing each piece by negative 2. It really helps. Because when I look at my final answer, y equals, we have to ask ourselves, what does this mean? Well, first let's talk about the signs. Negative divided by a negative is positive. And then I know that I have an invisible 1 in front of the x, so this becomes 1 half x. And then I ask myself, what is negative 6 divided by negative 2? Well, that's a positive 3. Now I am ready to graph. I know m equals 1 half, and I know b equals 3. We'll use b equals 3 first. Here's my y-intercept, and from there we'll count. This is a set of directions, up 1, right 2, up 1, right 2, up 1, right 2, or I could have done down 1, left 2, down 1, left 2. That's plenty of points, and we will graph nice and neat, nice and straight. See if I can get mine to line up just a little bit more. And again, because it is a line, we need to make sure we have our arrows on both ends. Let's check. Positive slope, increasing line, check. Process does not change for number 11. Our focus, if it helps to highlight that y value. That is our focus. We're working on getting y by itself. So first I ask myself, can I move something over using addition or subtraction away from this side? And the answer is yes. This positive 5x, I can subtract 5x from both sides. That leaves negative 4y equals, again, these are not like terms, so I have negative 5x plus 16. Now we're going to show ourselves dividing each piece by negative 4. So we have y equals, negative divided by negative is a positive. 5 is not divisible by 4, so we're going to keep it 5/4 x. Positive 16 divided by negative 4 is a negative 4, and I'm all done. I know my slope is 5/4, and I know b, my y-intercept, is negative 4. So I plot negative 4 first, that's my y-intercept, and then to count, we're going to count up 5, right 4, up 1, 2, 3, 4, 5, right 1, 2, 3, 4. I also could have gotten a point the other direction. The opposite of up and right is down and left. Down, 1, 2, 3, 4, 5, left, 1, 2, 3, 4. And we're all set. Let's draw our line. I'll fix mine. Make sure you're using that straight edge. And again, lines go on forever and ever, arrows on both ends. This wraps up really the skills portion of what our review is all about. And we're going to move into our real-world applications. Number 12 says, Mr. Rodriguez hired an electrician to update several electrical outlets in his home. The electrician charges an initial fee of $80 and $45 per hour. Let X represent the number of hours the electrician works. So as soon as I see a variable defined, I want to do something to make sure that it stands out. It tells me X represents the number of hours. Write a linear function to model total cost. So I know when I define my variables, X equals number of hours and Y equals total cost. Now, really focus on the question. The question is asking me to write a linear function. Well, what's a linear function? Slope-intercept form. We are looking for y equals mx plus b, where m is the rate of change and b is the y-intercept, or more accurately, let's call that initial value. Sometimes I see people getting these backwards, so to try to help with that, let's actually state first what's m, what's b. So m is a rate. I'm looking for keywords like per hour, per day, each week. It's a rate. It continues. It's not a one-time fee. Here, I clearly see my rate is $45 per hour. That will be for m. Initial value is a flat rate fee. Here I have an initial fee of $80. B is 80. Putting this together to become my model, y equals 45x plus 80, and I'm done. (13) and 14, we are back to our real-world modeling. In the hint sheet, I clearly outlined our 3 steps. 1 is to define our variables. 2, ordered pairs. Write your ordered pairs. 3, set up the work. So let's practice this with number 13. You start downloading a movie at 7 p.m. and then go do homework. At 9 p.m., you find that 575 megabytes have been downloaded. What is the average rate of change per hour in the amount downloaded? So to define our variables, I know that I have time, measured in hours. And then y will be downloads measured in megabytes. So I have my ordered pairs. That was step 1. Defined my variables. That was step 1. We defined our variables. Step 2 will be getting our ordered pairs. So when we go through and look, I see 7 p.m. and that's when you started. So if you just started, you have to reason how much would you have downloaded if you haven't downloaded anything yet. So that would be 7 comma 0. At 9 p.m., 9, you've downloaded 575 megabytes. Step 2 is complete. I have my ordered pairs. Last but not least, step 3, we are ready to do our calculations. And this is where I really tried to stress with you to make sure that we keep this nice and neat. If we keep it nice and neat all the way down, it'll make the labels at the end much easier. So we have 575 minus 0, change in y up top, divided by 9 minus 7, equals 575 divided by 2. Which is 287.5. Now, to figure out what our labels are, this is where showing this work nice and neat really helps. Because when I trace back and I look, I see that my y values are up top. And I look at my labels, megabytes is y. Per what? Well, let's look. X is all about hours. So my download rate is 287.5 megabytes per hour. We're going to follow the exact same 3 steps for number 14. So first, let's define variables. After working for 8 hours, Sally Joe made $60.80. At the end of the week, Sally Joe worked a total of 39 hours and made $296.40. Find the average rate of change per hour. Well, first let's define some variables. So I have time and I have money. Time will always be my IV, my independent variable, and here we're measuring hours. Y is salary, or amount made, however you would like to say it, in dollars. Step 1 is done. We've defined our variables. Step 2, ordered pairs. Well, she works 8 hours and makes $60.80. At the end of the week, she's worked 39 hours and made $296.40. Let's find our rate of change. Change in y divided by change in x. Again, the focus. Keep this nice and lined up, organized, neat. So we have 296.40 minus 60.8 or 0.80, whichever. You don't have to have the zeros, but if you like them, have them. What I'm trying to say is 60.80 and 60.8, same thing, your choice. Okay, back to the math. So change of x in the denominator. If I started with 296 in the top, I have to start with 39 in the bottom. So 39 minus 8 equals 235.6. Let's try that again. 235 divided by 39 minus 8 is 31. We'll divide to get our decimal unit rate, which should come out to be 7.6. Again, remember, the real world meaning is key here. So if I look up top, y is up top, y is money. So this is $7.60 per. When I look at the denominator, x is all about hours. So her average rate of change, or her average salary is $7.60 per hour. So notice 14 and 15, exact same setup. First, defined variables. Second, get your ordered pairs. Third, do the math and get a nice label on there. 15 is a continuation of the same. You're camping at the family cabin in the mountains. At 3 p.m., when you checked to the thermostat before lighting the fireplace, it was 61 degrees Fahrenheit. When you went to sleep at 11 p.m., you noticed the temperature was 85 degrees Fahrenheit. What is the average rate of change in temperature? Well, let's see. First, define variables. X equals, Y equals. Time is present. Time will always be my X value. My Y value will make our temperature because that is the second measurable quantity and it's being measured in Fahrenheit. I have my variables. Let's get some ordered pairs. At 3 p.m., the thermostat read 61. At 11 p.m., the thermostat read 85. We're ready to do the math. Change in y divided by change in x equals, let's start with 61. So 61 minus 85 divided by 3 minus 11. (61 minus 85 is a negative 24 divided by 3 minus 11 is negative 8. Negative divided by negative is positive. 24 divided by 8 is definitely not 8. Let's try that again. That's a bad 8. Let's try that third time. There we go. Negative 24 divided by negative 8 is 3. Again, though, I need my labels. So when I trace up top, y is all about Fahrenheit, so 3 degrees Fahrenheit per, and in the denominator I have x. X is hours. So the average change in temperature was 3 degrees Fahrenheit per hour. Number 16 is an interesting question. It's very easy to overthink it. Okay, it says the graph shows the amount of money in your bank account during the course of the year. Calculate the average rate of change. Recommendation. Let's just agree on some ordered pairs first. So for example, you could choose any two ordered pairs you want on the line. I think this one makes for a nice point. 0, 800. And then maybe here. The question is, what do I write for my x value? I can't write J. So we look here, I have January through December. Well, in the real world, we don't just have letters. We also call this month 1. February, the date, when you write February's date, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I can write 6, comma, and if I look, I'm halfway between 400 and 600, making this 500. Let's calculate the slope. So I'm going to stack my 2 points. Change in y divided by change in x would be 500 minus 800 divided by 6 minus 0, negative I got negative 300 divided by 6. Which, when we divide to get a final unit rate, would come out to be negative $60 per month. Very nice. All we needed to do was find slope. We've got our slope. We're done. Just be careful with making sure we see things like halfway between is 500. 17 is a blast from the past. We worked with tables a lot. Let's see how we can work with this one. The following table shows the cost of a movie ticket from 1987 through 2009. Calculate the average rate of change for the following intervals. Number 17 says the following table shows the cost of a movie ticket from 1987 through 2009. Calculate the average rate of change for the following intervals. So this is a great example of how to work with a table and intervals. These are both x values. So really what this is saying is when x is 0, what's y? And when x is 22, what's y? Some good questions came through on Remind about, well, I don't see 0 and 20. In the hints that I wrote, though, we need to remember what it means to have a 0 year. So 1987 is my initial year. So this will be my 0 year. If I were defining variables, x equals number of years since 1987. And then y would be my price. So then to figure out the following values, I would do 1991 minus 1987 would be 4, and so on. So this would be 1995 minus 1987 is 8. And I could keep subtracting. 1999 minus 1987, 12. 2003 minus 1987 is 16. 2007 minus 1987 is 20. And last but not least, 2009 minus 1987 is 22. Now I can get my points. So, using the table, I clearly see that when x is 0, y is 3.91, and when x is 22, meaning 22 years after 1987, the price was $7.50. And now I can continue and calculate change in y divided by change in x. It would be 7.50, 7.5, minus 3.91, divided by 22 minus 0 equals 3.59 divided by 22. And I'll keep dividing until I get my unit rate. So this would be 0.163. Again, real world meaning is key, so I trace across. Y is in the top. I can look here, I can look here. Either way, y is always price. When I look in the denominator is all about x. X is years. So when we talk about $0.163, what we're really saying is 0.16 cents, 16 cents. Increase of 16 cents per year. Same approach for B. We again have an interval, meaning these are both x values. So I ask myself, when x is 8, what's y? So I go to my table, 8, 4.35. 20, go to my table, 6.88. Change in y, 6.88 minus 4.35, or you could have done 4.35 minus 6.88. Remember, order is your choice. We should get the same answer. This gets me 2.53 divided by 12 equals 0.211. Real world meaning is still money per year, dollars per year. So this would be an increase of 21 cents per year. And we're done. Moving on to 18. Determine if the functions are parallel, perpendicular, or neither. The key here, and the hint that I wrote, was to determine this, we need to have slope-intercept form, meaning both lines have to be solved for y first. We have to have this form for both lines. So if I check y equals 3/5 x plus 8, that's all set. This one is not. So to solve for y here, we're going to subtract 5x from both sides. These are not like terms. So I get negative 5x plus 18. Show myself dividing both, or each piece, by 3. My resulting function will be y equals negative 5/3 x plus 6. Now I have two functions I can compare. So if I look at their slopes, we're comparing 3/5 and negative 5/3. These are opposites. One is positive, one is negative. These are also reciprocals, 3/5 and 5/3, which means that I have a perpendicular relationship here. Perpendicular functions. Because we have opposites and we have reciprocals. When I look at example B, I see that neither of these are solved. So we'll take them one at a time. So we'll start with y minus 5 equals 6x. Trying to get y by itself, so we'll add 5 to both sides. There's one. Here's the other. Now that we have slope-intercept form for both functions, let's compare slopes. 6, 6. These are the exact same slope. And I also notice that my y-intercepts are different, which means we have parallel lines here. Because they're increasing at the same rate, but because the intercepts are different, they're not the same line. If both of these read, for example, y equals 6x plus 5, it would be one line right on top of the other. But because the y-intercepts are different, I know that they will never cross. Or, excuse me, I know that they're not the same line. (19) So, just to summarize for 18, the importance, make sure they're both solved for y first before making your comparison. When you are making your comparison, remember what we know about perpendicular and parallel lines. Perpendicular, you have to have opposite reciprocals. For parallel, the slopes have to be the exact same, but also make sure that we just double check that the y-intercepts are different, which means we have two different lines, not the same line. Number 19, the net profit at the West City hardware store over the last few months is shown on the graph below. Here's our graph. Here's our function. If the y-intercept was changed from 20 to 40 in the equation, how would this change the graph of the equation? So really the key is to remember what effect does this have. The y-intercept is where the graph crosses the y-axis. So, if we were to change that value from 20 to 40, notice there was no comment that the rate of change would be different. We would literally be shifting the entire graph up. Let's see which answer choice matches that action. The line segment would be more steep. Well, we know that's false because we haven't done anything to the rate of change. Notice, nothing has happened to m, so can't be A. Line segment would shift up. That is seeming like a good choice. Let's just double check the rest. The line segment would shift down. Nope, it shifted up, not down, so it can't be C. Line segment would be slanted up instead of down. This is still a decreasing segment. It didn't suddenly start increasing. So, B is the winner. Line segment would shift up. Numbers 20 and 21 were really asked to make sure we understand what it means to have a slope, what it means to have a y-intercept. It says the linear function f of x equals 3x plus 5 models the amount f of x in billions of dollars that the music industry spent on marketing their artists X years after 2000. Describe what the slope and y-intercept represent. So defining our variables, when we read for information, we know that x is number of years after 2000, and y is amount in billions. Money spent in billions. When I look at my model, we're paying attention to this to identify M and B. M is 3, B is 5. I'll make that a little neater. Okay. So now we're looking at what do these two values mean? Well, I know that M is a rate. So this will be still that idea of change in Y divided by change in X. Y is the amount spent in billions. So this means $3 billion per, when I look at X, years. $3 billion per year spent on marketing. B just going to move this down a little bit. B equals 5. This is my initial value. So I have to ask myself, what's my 0 year? 2000. So this means that in 2000, $5 billion was spent in that year. That is my starting value. In 2000, because that's my 0 year, $5 billion was spent as my initial value. Let's apply the same idea to 21. At Fran's Flowers, Fran sells and delivers flower arrangements. It costs $39.99 for every Valentine's Day arrangement and $11.95 to deliver. Write a linear function to model this real-world scenario. So I don't really have variables given, but we can define them based on what we see here. Here it tells me $39.99 for every or per Valentine's Day arrangement. So X represents number of arrangements. And then once I know how many arrangements have been sold, we know profit. I also notice that I don't have a function given here. So now we are mentally going to look at, if I were looking to write y equals mx plus b, what would m be? And what's b? M is a rate. So let's see if we can go find it. $39.99 for every Valentine's Day arrangement. would be my rate. It's per arrangement. So I have M equals $39.99 per arrangement, or you could write out the words. It's going to bother me. Sorry guys, let's make that neat. Per good enough. Okay, $39.99 per arrangement. And then B, I'm looking for a flat rate. Let's see. I have a delivery cost $11.95 to deliver. That is a one-time fee. That is my flat rate. B equals $11.95. Flat rate. And I'm done. Clearly showing an understanding of what is M and what is B and what does it mean. These remaining questions tie directly into what we've been doing these last couple of days with, can we apply our knowledge of slope-intercept form and point-slope form to real-world questions? So, let's look at this first example. The graph below models the amount of money spent on fast food over the past 8 days. Calculate the average rate of change between the indicated ordered pairs. Describe what this value represents. Average rate of change means slope. We are experts at calculating slope. When I look at my graph, I have two very nice ordered pairs given to me, 0, 27, 6.5, 13. So that's what we're going to use. 0, 27 and 6.5, 13. So I have change in y divided by change in x will be 13 minus 27 divided by 6.5 minus 0 which gets me negative 14 divided by 6.5. Let's divide for our unit rate, and that equals negative 2.33. Well, negative 2.33 what? What did we not define? Let's go back. Variables. X equals, Y equals. When I have a graph, it's really nice because I can just look at the labels on the graph. X is clearly number of days. I'm going to look at my Y value on the Y-axis, amount spent. So now I can go back and say, well, Y, change in Y, represents money. X in the denominator is days. So amount of money spent on fast food over 8 days is decreasing by $2.33 each day. So minus $2.33 per day. Now we're asked, write a linear function to model the amount of money. Linear function, our goal is y equals mx plus b, which means we need a slope and a y-intercept. We just found the slope. Here's m. The question is, do we have b, and does the graph give us that? So I check. This is definitely not a y-intercept. How about this point? 0, 27. Hey, look. Graph gives us b. b equals 27. So that means I can pull that value into my model right away. So my model will be y equals negative 2.33x plus 27. We calculated slope. To write our model, we check, does the graph give me my initial value? If it does, that's very nice, because then I can just pull it into my equation and use it, and I'm done writing my model. Let's see how 23 compares to what we just did in 22. The cost to make a chair changes depending on, pretty sure that's supposed to say how. How many chairs are produced. The following graph depicts this relationship. Calculate the average rate of change between the interval 10, 130 and describe what this value represents. So first let's get variables. X equals Y equals. When I look at my x-axis, I see X is number of chairs produced. When I look at my y-axis, cost in dollars. Now, I notice I'm given an interval. 10, 130 is an interval. So our two ordered pairs will be 10, something and 130, something. So let's go to the graph. 10, when x is 10, what's y? Here I look, 45. So 10, 45. And then when x is 130, what is my y value? I look across, I'm at 30. So 130, 30. These are my two ordered pairs. So I'm working with 10, 45 and 130, 30. Now that I have my ordered pairs, I can calculate change in y divided by change in x would be 30 minus 45 divided by 130 minus 10. 30 minus 45 is negative 15 divided by 130 minus 10, which is 120. Dividing for the unit rate, we get negative 0.125. In terms of our real-world meaning, change in y up top is money divided by change in x in the bottom, chair. So the cost is dropping roughly 12 cents, depending on how you choose to round. I would accept 12 or 13. per chair. So with every chair produced, it costs less to make, which makes sense. So when people start producing things in mass, the more they make, the less it costs to make it. Minus 12 cents per chair. Okay. B says write a linear function to model the amount of money spent in terms of the number of chairs produced. So again, our goal has not changed. We are looking for y equals mx plus b. In part A, I got m. That's nice. But when I look at my graph, this graph does not give me b, which means I have to pull out a tool in my toolbox. We need point slope form. So we get to choose whether or not we want to use 1045 or 130, 30. I'm going to say, for me, I like using that first point, 1045. So using 1045 and that slope we just found, m equals negative 0.125, we're going to substitute these values into point slope form. Y minus y1 equals m times x minus x1. Let's see what this will become. Here is my x1, y1. So this will become y minus 45 equals negative 0.125 times x minus 10. We've correctly set up point slope form. Now the priority is to solve for y. When I look at this, we're going to make a decision to leave y minus 45 alone for the moment. Let's distribute negative 0.125. So I have y minus 45 equals negative 0.125x and then we need to do negative 0.125 times negative 10. Negative times negative is a positive, and in the calculator I get 1.2. Last step would be to add 45 to both sides. Resulting in y equals negative 0.125x plus 46.2. I have accomplished y equals mx plus b. We are all set with this question. Last but not least, number 24. From 1980 to 2011, the number of clothing stores in Connecticut has been increasing. In 1985, there were 340,000 different clothing stores in Connecticut, and by 2000, there were 345,250 stores. Let X represent 1980. That's key. So let's define our variables first. X is number of years. Since 1980. and y will be number of clothing stores, because these are the two measurable quantities that are being discussed here. So we have this idea of a 0 year. 1980 is my 0 year. B asks us to calculate the average rate of change and describe what this value represents. Well, to calculate a rate of change, we need points. So let's see. I know in 1985, there were 340,000 stores. But when I look at my definition of x, x is the number of years since 1980. So this ordered pair actually becomes 5, 340,000, because 1985 is 5 years after 1980. Next, I look and it says in the year 2000, there were 345,250 stores. I need to figure out how many years after 1985, how many years after 1980 is 2000. So 2000 minus 1980 is 20. So my second ordered pair becomes 20, 345,250. Now that I have my two ordered pairs, we can calculate slope. Change in y divided by change in x. Let's say I choose to start with 340,000. I would subtract 345,250 divided by 5 minus 20. If you chose to start with this value, that's fine. Just remember that order matters. So in the denominator, you would start with 20. When I subtract 340,000 minus 345,250, I arrived at 5,250 in the top, in the numerator, divided by 5 minus 20, which is 15. Dividing to get my unit rate, I arrived at 350. To know what this means, I trace back across. Y is in the numerator. When I look at my variables, Y represents the clothing stores. So 350 stores per, looking at my denominator, x is years, this is a positive slope. So it means that between 1980 and 2011, the number of clothing stores increased by 350 stores per year. Okay, I have my rate. C says write a linear function to model the number of clothing stores in Connecticut. So again, linear function. Goal is y equals mx plus b. I know m. We just calculated m. The question is, do I know b? Really think about what that would mean. My 0 year is 1980. That's my 0 year. Do I know how many clothing stores were in Connecticut in 1980? Let's see. I know 1985 and I know 2000. I do not know 1980. So we do not have our initial value given to us. We need to make a choice. Do we want to use this first point or the second point? I'm thinking most people will choose the first one. The second one would work out just as fine. So if you use the second point, we should end up at the same answer. So we need to pull that tool out of our toolbox. Point slope form. Using a point, in this case the point will be 5, 340,000. And that slope we just calculated we will be substituting into y minus y1 equals m times x minus x1. Here is my x1, y1. So this becomes y minus 340,000 equals our slope, which is 350, times x minus 5. Leave the left side alone for a moment. We're going to distribute 350. So I get 350x. 350 times 5 in the calculator would be minus 1,750. To finish solving for y, we'll add 340,000 to both sides. And we get y equals 350x plus 338,250. And we're done. So, in terms of what that would actually mean if I asked, in 1980, in our 0 year, that's how many stores existed. That's my 0 year amount. 1980 is the 0 year, my initial year. That's how many stores were in Connecticut. Great job. Any questions, please feel free to send me a remind, take a picture of anything you're working on, and I will get back to you as soon as I see your questions. Happy studying.